Look up on a clear night, and you'll see darkness between the stars. That darkness shouldn't exist. By every reasonable assumption about a vast universe full of stars, the entire night sky should blaze as bright as the surface of the sun. So why is it dark? The answer is one of the most important clues we have about the universe itself. The problem is older than you'd think. In 1610, Johannes Kepler noticed something strange. If the universe were infinite and filled endlessly with stars, then no matter which direction you looked, your line of sight would eventually land on the surface of some star. Maybe near, maybe unimaginably far, but it would hit one. 2 centuries later, in 1823, the astronomer Heinrich Olbers described the same puzzle, and his name stuck to it. Olbers' paradox. Here's why it's a paradox. Imagine standing in an infinitely large forest. Look in any direction and your gaze eventually meets a tree trunk. The forest forms a solid wall of wood. Now swap the trees for stars. In an endless, eternal universe, every single point on the sky should sit on a star's surface. And it's worse than just a few extra stars. Distant stars look fainter, yes. Brightness falls off with the square of distance. But the farther out you look, the more stars you find, and their numbers grow with the square of distance too. The two effects cancel perfectly. Each shell of sky, near or far, contributes the same total light. Stack up infinite shells and the whole sky should glow with the brightness of a stellar surface. The night sky and the daytime sky would be a uniform sheet of blinding light as bright as the sun, in every direction at once. We would not survive it. But we do. The night is dark. Something in our assumptions must be wrong. For a long time, people reached for easy fixes. The first guess, maybe clouds of dust and gas between the stars soak up the distant light. It sounds reasonable, and it's wrong. Block radiation long enough and the dust heats up. Given enough time, it would glow just as fiercely as the stars it was hiding. You can't hide that much energy. You can only delay it. A second guess. Maybe the universe simply isn't infinite. Maybe it ends, so there aren't enough stars, but that doesn't save us either. Look deeper into space, and you keep finding more galaxies, each packed with stars, their combined light piling up the farther you peer. A 2016 survey estimated the observable universe holds roughly 2 trillion galaxies. There is no shortage of stars. So if there's no shortage of stars, and nothing is hiding their light, why is it dark? The first person to glimpse the true answer wasn't an astronomer at all. It was the writer Edgar Allan Poe. In an 1848 essay called Eureka, Poe suggested that the most distant starlight simply hasn't reached us yet. There hasn't been enough time. He was right. The universe is not eternal. NASA's WMAP mission measured its age at 13.77 billion years, accurate to within 0.5%. The universe had a beginning, and light has a speed limit. It travels fast, but not instantly. So we can only see objects whose light has had time to arrive out to a bubble around us, roughly 13 billion light-years in radius. Beyond that edge, there may be endless stars, but their light is still in transit. It hasn't gotten here. Inside that finite bubble, there simply aren't enough stars to cover every line of sight. Most directions you look, your gaze sails past the stars and out into empty space, into time before any star had formed. The darkness between the stars is the universe being young. But here's the twist that makes this beautiful. The sky isn't truly dark. Look with the right eyes, and it does glow uniformly, exactly as Kepler imagined, just not in visible light. In 2024, NASA's New Horizons spacecraft, far out past Pluto, where the inner solar system's dust doesn't blind it, measured the faint combined glow of all the galaxies in the sky. About 11 nanowatts per square meter, a real measurable wash of light from everything that has ever shone. And there's something deeper still. Point a microwave detector anywhere in the sky, and you'll find a steady hum of radiation at 2.725 degrees above absolute zero. This is the cosmic microwave background, the leftover light from the Big Bang itself. It comes from a time 380,000 years after the beginning, when the entire universe glowed at around 3,000 degrees, like the surface of a cool star. So Olbers was almost right. Every line of sight does end on a wall of fire, the glowing infinite universe. But the expansion of space has stretched that light by a factor of about 1/100, cooling it from blinding visible light all the way down into invisible microwaves. The blazing sky is still there. It's just been redshifted into the dark. So the darkness overhead is not emptiness. It's a measurement. A dark night sky tells us the universe is not infinitely old. It had a birthday. It tells us light is finite, and the cosmos is still too young for the most distant starlight to arrive. And it will not stay this way forever. Stars don't burn forever. One like our sun lasts about 10 billion years, and star-forming gas runs out. Astronomers project that in roughly 1,000 trillion years, the last stars will gutter out, leaving only white dwarfs and black holes drifting in the cold. The night sky is dark because the universe is young and lit by stars that won't last. Look up, and you're not seeing nothing. You're reading the age of everything.